thanks for yeah, thanks for watching our presentation of KiiChain. So in this time, I was going to explain about how our KiiChain, what is the framework using on our KiiChain, and what is built for the goals of our KiiChains, and how we can deploy the validators, and what we needed to do run our validators, something like this. Yeah, I'm going to explain from scratch. Actually, this is the KiiChain project, and you can download this project from our GitHub repositories. So actually, our KiiChain project is based on the beta change Polaris. So we fork this Polaris to provide EVMs in the Cosmos integrations. So as you know, to run the this Polaris blockchain, we needed to install some requirements, like as the Golangs and the foundries. So in my cases, I installed foundries on my locals. So yeah, so I already installed this foundry on my local. So if you want to run the validators on your local, you have to install the foundry before run our project. So yeah, I will explain how we can deploy the validators from scratch. So let's start. So first, if you install the foundry app, then you have to build our project, yeah, like this. So this is the first steps for building our project, building clean our project, and it will take some time. So after build clean up, then you have to check the entry point.sh. This is the cell comment, and this file is for modifies variables between the sections. So there are several sections, and here is the start configurations, and this is the account keys. And if you want to add some several keys, yeah, you can add here as your mind. So right now we are using the two keys. One is the validators, and second one is the Genesis tokens. And this is the initial balances of these accounts. So you can set it here as well. And there are several sections as the seed phases, and this is the initial EVM account as well. And this is the initial balance for this EVM accounts. And this is some chain infos of our chains. So right now I set as the KiiChain -1s, and this is the Monica of the validators, and this is the keyrings and something configurations you can set at here. And also there are some peer address here. So this is for connecting to our validators, yeah. And it is the home dir and app tomos and this something like this configuration we already set, so you can change or configure easily or before running the chains. So kinds of this configuration we already set. So as a share comment, so you can check like this, and then let's run the share file first. Yeah, you can check like this. And after this, we can start our node using the make command. So like this, then I think something histories remains. Okay, wait. So it is because I already using this port. Yeah, as you can see, you can start a node on your local like this. And yeah, as you can see, it the block from the zero from 1 to 3. As you can see, the block height increase. It means the node working normally. So after running the node, uh, you have to connect our keychains. As you know, you have to download our Genesis, and you have to run with this Genesis. But we already provide our Genesis on our project. So this is the Genesis directories, and you can check this Genesis JSON. This is our Genesis. So you can use this Genesis for running our validators on Node. So to run this Genesis, yeah, I will run with this Genesis. So Genesis, just the PNP KiiChain. Genesis. Yeah, I will copy these Genesis to these directories, and after that, I have to reset all the blockchain infos before I running for testing. So for this, yeah, I run this command met and save reset all, and we set the home directory like this. So yeah, as you can see, we set home dir like these directories. So you have used this as the home dir. So yeah, and after run this command, you can see removed all existing address book and all the blockchain histories are removed, and also reset all the private validators infos with for using our new Genesis. So after run these files, you can run the validators with our Genesis. So yeah, and one thing is that before run our Genesis, to connect our validators, we have to uh, input our PO address. So this is at here. So we have to import our Genesis at here. So we already copied this one. Yes, this one. So let me check. So I think then we prepared all configurations for run our node to connect our validators. So let's run the node train start. Maybe there are some configures we needed to set. Let's log level as infos and API enabled and save. Maybe false. And as depends on your requirements, these configurations are not required. So if you want to some uh, settings, you can use this command. Or if you don't want to any requirements. You don't need to set these requires on for running your node. The minimum gas price is we need to one key. This is our daemon. So and one is the home TMP check. Yeah. So like this, yeah, we can start our node with connecting our validator. Um, um, uh, sorry. Yeah, I prepared the with let's use this one. Yeah. So yeah, like this. So as you can see, we start running the node and yeah, it will connect our validator using this field's address. Let's check. Um, seems like cannot dial our address. Yeah. So let's wait until the run the validators. Uh, let me check the configures. Why it's not? Uh, yeah, let's wait. Okay. So yeah, I set this address to persistence fields, and as you can see, we not connect again. Let's wait. Yeah, it's maybe yeah. I think something like it's connected to our validators. So yeah, as you can see, they are synchronizing the block with our current key chains. So this means we connected to successfully to our validators. So it means you can run the node, our keychain node on your locals. And the next one is the uh, connect our change and becomes our validators. So to do this, yeah, first one, you need to make some validator.json. Using for this, you have to generate the EVM address first. So uh, for building this, you can check, you can use this command for making the address. Yeah, so this is the template. I will create some sample validators. So this is the template. We already uploaded this format on our repository readme files, so you can check on it. So this means you first one, you have to replace this public key at here, and you can set some initial amount and the memory card and identity. So you can set this kind of information as you want, and after this, you can run the keychain export. So for this, you export for this one, key export, and there are some parameters at here. So there are names, and some home strings and querying backend you can set. So we already set template on our GitHub repository, so you can check on it. So this is the template. And at here, you have to set the account name registered at here. So we set here validator, so you can check it validator as well. And after that, yeah, you can check getting this private key for EVM wallet. So this is your validator address for EVM. So you can go to MetaMask and import this wallet address on your MetaMask, and then you can check some key tokens. You can force key tokens at here. After that, you needed to stake our validators to become real validators of our keychain. Yeah. So all of these descriptions are already uh, presented in our repository, so you can check on our repository limiter files. Yeah. So yeah, this is my presentation for how we can deploy our validators and how we can use this one for staking as well. Yeah. So this is for me.
Thank you so much, Sequoia. That was pretty interesting. So now, let me introduce myself. My name is Andre Ramirez, and it's a pleasure to me for being this again. I hope we continue doing different workshops. At this point, we are going to see how to create an infrastructure, in a specific, an AWS infrastructure, about how to deploy smart contracts or how to create a smart contracts deployer. So we are going to use Hardhat, in specific the HRE, that is an instance of Hardhat. And the idea is to create a script which receive the smart contracts code, like the Solidity file, and then it will deploy into the blockchain, and then upload automatically the API and also the source code. Right. So to do that, we need to import the different requirements or the dependencies. In this case, we are going to create a CLI2. That is because we need JARX. You can use JARX or another tool for creating CLI. In this time, we are going to create the tool using TypeScript. So everything you see, it's made with JavaScript dependencies and the TypeScript types, right? So we are going to import the different dependencies. In this case, as I said, JARX. This is the path, the Hardhat instance, FS for using or handle files and folders. AWS because, as I said, we are going to use AWS DynamoDB, and also we are going to mention how to use using Lambda. And finally, the .env for using our environment variables. So first, we need to import our config file because we need to create the hardhat.config file. This file has the most important settings for our project. In this case, the Solidity version, the name of the contract. In this case, this name is typed, but the idea is to have a front end with the field where you can type your smart contract name. Then you have the constructor arguments, and this depends of the smart contract. So the idea is that this item will be dynamic. I mean, you have a field where you can add the amount of different input arguments, and obviously it depends of your smart contract. If your smart contract doesn't need an input arguments, I mean, doesn't need the constructor argument, is empty. But if your smart contract need a list of different input arguments, you have to type those here in this field. Then we specify the paths if we need to move or if we need to change the path of the different output of Hardhat. For instance, where is the smart contract is the source. For the or by default is located into the folder called contracts. That is this. But if you need to change, you just have to change this field. At the same point is with artifacts, and artifacts is the result of deployed and smart contracts, and also with compile. Then this is the most important part, and is where we define our network setting. So this is our RPC URL, the chain ID, and this is your API key, where which will deploy the smart contract. This API key you will find into your MetaMask account in the detail. When you want to show or to see your account detail, you can find your API key. So let's continue with the code. The most important part is this one, where we deploy the smart contract. So as we said, we have defined the path of the smart contract. Let's review, is in this folder, is in contracts. So the the instance of Hardhat will take the smart contract or the smart contract located in that file. After find the smart contract, it will compile those files and create the artifacts and cache folders. Remember, the artifacts is the folder where you can find the result of your compile process. For instance, the ABI and other results. Then we need to deploy the smart contract. In that case, we use this one, this line of code, create a factory with the defined or the smart contract that we have defined. Then we need to deploy with this line. We use the deployed method and we send the different constructor arguments. Remember, if your smart contracts doesn't need any constructor arguments, just let this empty and everything will works perfectly. Then we wait until the contract is deployed because it depends of your internet connection and also it depends on your fee or your amount of tokens that you have. If this part is correct, our smart contract has already deployed and successfully deployed. Then we need to automatize the process of extract the ABI and store the source code and the ABI. That idea is to have, for instance, in your Explorer on your the app, the way to see the smart contracts code and also the ABI. If someone needs to refers to your smart contracts, is an easier way to check the ABI or the source code. So to do that, first we need to find where is that folder, where is that files located. I mean, we need to search where is the ABI and also where is the source code. So remember that we have, or it's a good idea to store the smart contracts into the folder called contracts. So in that folder here, we found the artifacts contract, and we check for files which ends with the extension .sol. Yes. So we know that here in contracts, in this case, this is the name of our smart contract, but it changed independent of your smart contracts. That is because this is a variable instead of just hard typing. So then we need to look for what is our ABI, and the ABI is located in this file. I mean, not in this file with the DBG, is in this file. Here you can see the ABI in this section. So we need to import the JSON file and then extract the ABI. So here is this process. We need to extract the JSON file and then extract the ABI. The same idea with the source code. We need to find where is the source code and then import or extract from the file. So we have said that the smart contracts are deployed or are located in this folder contracts, and this is our smart contract. So in the code, we are looking for path that ends with the extension .salt into the folder called contracts. Then we need to read the information or extract the text with this method. And then we need to upload into DynamoDB. So this is the idea. Let me check. Let me change. Nice. So this is a basic is a diagram about what we are going to do. We are going to create an infrastructure, a little basic infrastructure, which you use an API gateway as a gateway for your application. You can send your smart contract the whole Solidity file, or you can upload the code. It depends on your application. Then the script that we are creating is executing by the AWS Lambda. It compile and then deploys the smart contract, and after the compile process, it extracts the ABI and the source code. Those files are located in the DynamoDB service in order to have an easier way to search the assets based on the smart contract address. For instance, you need to and search a smart contract address, and then you need to see the ABI or the source code in order to have a reference or understand how to use that smart contract. So let's continue with the code. Perfect. Now we are going to upload the assets into our DynamoDB. To do that, we need to first create an instance of the AWS config and specify our access key and access secret key. Remember, those keys are located or are created by the AM service in AWS. You need to create an user and then get the access key and the secret key. This one is located into our .m file, and you can find using the .m extension or .m tool. Then we need to create our item with the information that we want to create. So In this case, this is the name of my table. You can change the table name, depending of what you want. And I use the contract hash as an ID. The idea is to search the smart contract based on your smart contract ID or based on your smart contract hash, and then upload the ABI and the source code. That is because when we want to search an smart contract information, we are looking for the smart contract hash, and then we receive the ABI and the source code. So in this case, this information is located in the contract deploy process. So here in the contract address, we need to change this. Let me check. Contract address. Okay, so let's fix it a little bit later. Then we need to put that item into our table. To do that, we need to just call this function with the params, and the params are the item, what we need to upload. Then we can just use the AWS Lambda. That is another option in order to enhance the way that we deploy different smart contracts, in order to just have a URL where you can just upload your files. In this approach, we need the file and we need the code. But if you add the AWS Lambda, you can have a different way to deploy smart contracts. I mean, you have an URL where you can just upload the file using Postman or any other programming language. It's a most difficult approach, but is more completed, right? And for instance, let's make an example. So we are going to deploy this smart contract that is for creating certifications. Is similar as the smart contract that we have developed in the previous workshop. To do that, we need to call this command npm start. Remember, we are using TypeScript. So npm start, use ts node, and we are calling the index file, which is located in source index.ts. Then we need to add these symbols, the slash or the dash, which means that we are going to send flags information, because if we avoid this information, means that this flag is for the npm, and no, this is for our CLI application. Then the slash f, which means this one, we have specified that one before here. With the f flag, we are going to define the path of the smart contract, or you can just use contract. Got it? So in this case, I'm going to use the F and then the path of the smart contract. Remember, that is located into contracts and then certifications.sol. If we launch this command, the compile process is completed. In this case, the result is nothing to compile, but if we just delete this one, the artifacts and cache, Hardhat will think that this is a new smart contract and it will be deployed in our KiiChain blockchain. So let's wait until this is finished. So this is the result. We have compiled the smart contract in 3 Solidity files, and then we have deployed the smart contract in this smart contract address. This one is the information that we need to put here. And with this smart contract hash, the ABI and the source code will be deployed into our infrastructure in AWS. Got it? So this is our approach. I hope you can use it in your application, in your hackathon projects, and I hope it helped you in your understanding process. Thank you so much. Well, that was everything for us. It was a pleasure for us for preparing this workshop. I don't know if Sikuya have something to say.
Yeah, nothing is for me. So yeah, thanks for watching my presentations and analysis. Yeah, thank you so much.
Thank you for watching.